Imagine a world where cutting-edge military technology collides with unrivaled power. Step into the extraordinary domain of the USS Gerald R. Ford, an awe-inspiring titan that stands as the largest and most advanced warship on Earth. Standing tall at a staggering 337 meters, this steel behemoth is a testament to innovation and strength. However, its current voyage towards Oslo, Norway, holds significance surpassing routine naval exercises. Brace yourself as we delve into a story of power, precision, and the pursuit of dominance. Stepping into the spotlight, the F-22 Raptor, heralded as the world's inaugural fifth-generation fighter, emerges with unparalleled grace from the depths of secrecy. A marvel of engineering, it possesses a repertoire of features that make it the epitome of modern aerial supremacy. With its cunningly crafted stealth capabilities, the F-22 Raptor becomes an enigma to radar systems, gliding through the skies undetected. This stealth, coupled with its breathtaking speed, grants it an air of invincibility, leaving adversaries in awe and trepidation. Yet, the F-22 Raptor's arsenal is what truly sets it apart from its counterparts. Painstakingly selected, each weapon embodies cutting-edge technology, engineered to deliver destruction on a scale previously unimaginable. These armaments, designed for devastating precision, have been carefully curated to confront the long-standing adversary of the United States, China. The F-22 Raptor's armament is designed for maximum lethality, leaving no doubt about its capabilities. Among its formidable weapons, one stands out: the AIM-120 AMRAAM. This advanced air-to-air missile is a true game-changer. Equipped with unmatched range and precision, the AIM-120 AMRAAM can engage multiple targets at once. With a range exceeding 100 miles and an active seeker, escaping its deadly grasp becomes nearly impossible for the enemy. The AIM-120 AMRAAM's active seeker technology allows it to autonomously detect and track enemy aircraft, ensuring it stays locked onto its targets throughout its flight. This means the F-22 Raptor can launch attacks from a safe distance, minimizing its own risk while striking with pinpoint accuracy. What sets the AIM-120 AMRAAM apart is its ability to engage multiple targets simultaneously. This gives the F-22 Raptors a decisive advantage, overwhelming enemy defenses and greatly reducing their ability to mount an effective response. In the world of close-quarters air combat, one missile takes the spotlight: the AIM-9X Sidewinder. This short-range heat-seeking missile is designed to engage agile enemy fighters with exceptional precision. With a range of up to 22 miles and impressive maneuverability, it poses a formidable threat in the skies. The AIM-9X Sidewinder is a deadly weapon that tracks its targets by homing in on their heat signatures. Once locked onto an enemy aircraft, it relentlessly pursues its prey, defying evasive maneuvers easily. Its ability to perform high G-turns and make quick course corrections ensures it stays on target until impact. With its advanced heat-seeking technology and remarkable agility, the AIM-9X Sidewinder is the weapon for close-quarters aerial combat. It delivers a potent punch, striking fear into the hearts of adversaries who dare challenge the F-22 Raptor and its lethal arsenal. In the fast-paced world of air-to-air combat, the AIM-9X Sidewinder embodies simplicity and devastating effectiveness. Its range, maneuverability, and heat-seeking capabilities make it an essential asset in the F-22 Raptor's quest for aerial supremacy. Prepare to witness the awe-inspiring ground attack capabilities of the mighty F-22 Raptor. This beast of a fighter jet packs a serious punch with its deadly weapon of choice, the GBU-32 JDAM, or Joint Direct Attack Munition. Get ready to see enemy ground forces reduced to dust. The GBU-32 JDAM is no ordinary bomb. It's a precision-guided weapon that brings chaos and devastation with unmatched accuracy. Guided by cutting-edge GPS and inertial guidance systems, this bomb homes in on its target like a heat-seeking missile. There's nowhere to hide when the F-22 Raptor is locked and loaded with the GBU-32 JDAM. But what sets the GBU-32 JDAM apart is its ability to dish out destruction on a massive scale. Picture this: multiple bombs unleashed from the F-22 Raptor, raining down upon enemy strongholds and armored vehicles. The result? Total annihilation. This bomb turns enemy ground forces into nothing more than a cloud of dust. When it comes to ground attacks, the F-22 Raptor means business. With the GBU-32 JDAM in its arsenal, this fighter jet takes no prisoners. Enemy installations, fortified positions, and anything that stands in its way will be obliterated in an instant. Imagine this. The F-22 Raptor, the ultimate aerial predator, faced with fortified enemy positions. But fear not, because it has a trick up its sleeve, the GBU-39 small-diameter bomb. These bad boys may be lightweight, but don't let that fool you. They pack a punch. The GBU-39 bombs are like precision-guided ninjas. They can penetrate the toughest defenses like bunkers and buildings with insane accuracy. It's like they have a GPS in their brains. Flying over 60 miles, they deliver destruction right where it's needed most. Just imagine the scene. The F-22 Raptor swoops in, launching these bombs from a safe distance. With surgical precision, they rain down on the enemy, obliterating their fortified positions. Walls crumble, defenses shatter, and the enemy is left scratching their heads, wondering what just hit them. What makes this even more awesome is that the F-22 Raptor can take out these fortified positions without getting too close for comfort. It's like a sniper in the sky, eliminating threats from a distance. The GBU-39 bombs are the Raptor's secret weapon, ensuring that no enemy stronghold is safe. So the next time you think of the F-22 Raptor, remember its trusty sidekick, the GBU-39 small-diameter bomb. Together, they make an unstoppable team, taking down fortified positions with ease. It's aerial warfare at its finest, and the F-22 Raptor reigns supreme. Suppressed. That's what happens to enemy air defenses when the AGM-88 HARM missile enters the scene. This bad boy is a high-speed anti-radiation missile designed to take out radar installations and electronic systems like a boss. With a range that stretches over 80 miles, there's no escaping its reach. And check this out. It's got multiple guidance systems, including GPS, infrared, and radar homing. That means no target can hide from its relentless pursuit. Imagine the enemy's radar sites abruptly switching from full power to complete shutdown. The AGM-88 HARM missile locks onto its emissions and boom! Say goodbye to their ability to track or engage our mighty F-22 Raptor. It's like flipping a switch and turning off their defenses. The enemy is left wide open for the next strike. With the AGM-88 HARM missile on board, the F-22 Raptor becomes an unstoppable force. It's all about taking control of the skies, baby. No more worrying about enemy radar systems giving away our position or targeting our aircraft. This missile is like a sniper, zeroing in on its target with deadly accuracy. So when it comes to suppressing enemy air defenses, the AGM-88 HARM missile is the ultimate game changer. It's a real game of cat and mouse, and guess what? The AGM-88 HARM missile always gets its prey. Its range, guidance systems, and sheer firepower make it an essential weapon in the F-22 Raptor's arsenal. When it's time to take out those pesky enemy radars, there's no better friend to have than the AGM-88 HARM missile. It's a one-shot knockout that leaves the enemy scratching their heads and wondering what just hit them. As the tension reaches its peak, the Raptor unveils its ultimate weapon, the M61 Vulcan cannon. This bad boy is a 20mm rotary Gatling cannon that unleashes a jaw-dropping torrent of bullets at an insane rate of up to 6,000 rounds per minute. When the Vulcan cannon kicks into action, it's like a symphony of destruction in the sky. Bullets rain down relentlessly, seeking out their targets with deadly accuracy. Those poor opposition aircraft don't stand a chance. The Raptor's firepower shreds them apart, turning them into honeycomb-like relics of their former glory. But wait, the U.S. Air Force and the F-22 Raptor crave more than just dominance in the skies. They hunger for a weapon that defies all known boundaries, a weapon that shoots faster, longer, and with unparalleled precision. Enter the realm of science fiction, where lasers reign supreme as the epitome of destructive force. Cue the Air Force Research Lab, the birthplace of innovation and collaboration. In their labs, they've cooked up something truly mind-boggling, the Self-Protect High-Energy Laser Demonstrator, or simply SHIELD. This compact airborne laser weapon, integrated into the F-22 Raptor, takes destructive power to a whole new level. Picture this. Meticulous scientists and technicians fine-tuning the SHIELD laser system, ensuring it's a reliable, efficient, and compatible killing machine. They've optimized the laser's power source, refined its cooling system, and honed its beam control mechanisms to deliver unmatched precision and accuracy. Now it's time for the shield laser to show its stuff. The F-22 Raptor takes to the skies, armed with this game-changing weapon. Advanced sensors detect threats and the laser locks onto its targets with deadly precision. With a burst of energy, the shield laser unleashes a blinding beam, tearing through the air at mind-boggling speed. Traditional defenses crumble as the laser strikes with unimaginable force, sending enemy aircraft spiraling toward the ground. Military leaders gather in awe, realizing the full potential of the shield laser system. Its ability to engage multiple targets simultaneously while causing minimal collateral damage gives the F-22 Raptor an undeniable edge on the battlefield. This unstoppable duo solidifies their position as the undisputed masters of the skies. As the laser-armed F-22 Raptors soar through the heavens, their lethal beams of light instill fear in the hearts of adversaries. Their unmatched speed, agility, and laser firepower herald a new era of aerial warfare. Brace yourselves, my friends, for this is just the beginning, a glimpse into a future where the convergence of technology and military might knows no bounds. The development process behind the shield laser system was no walk in the park, my friends. It brought together the brilliant minds of Northrop Grumman, Boeing, and Lockheed Martin, giants in the defense industry. Northrop Grumman stepped up with their expertise in the beam control system. This bad boy ensures that the laser hits its mark with pinpoint precision. No room for errors here, folks. Next in line is Boeing, bringing their A-game with the crucial pod subsystem. This beauty seamlessly integrates the laser onto the F-22 Raptor, making sure it's ready for action whenever and wherever it's needed. But hold on tight, because here comes Lockheed Martin with their ultimate weapon, Lance. This laser system is a compact powerhouse like no other. Emitting a focused and intense beam of light, it packs a punch that's hard to comprehend. When this baby strikes, targets are in for a world of pain. The shield laser system is the result of this dream team collaboration. It combines the best of the best, pushing the limits of what's possible in warfare. Picture this, a beam of light so precise it hits the bullseye every single time, and it does it fast, my friends. Blink and you'll miss it. So, when the shield laser is unleashed, the F-22 Raptor becomes an unstoppable force. It's like watching a sci-fi movie come to life. The laser's intense focus and lightning-fast speed leave adversaries shaking in their boots. There's no escape from the wrath of this advanced technology. Deep within a top-secret, high-security laboratory, a team of brilliant scientists is hard at work fine-tuning the mind-blowing shield laser system. These guys mean business. They meticulously put this cutting-edge weapon through its paces, ensuring it's reliable, effective, and perfectly compatible with the fearsome F-22 Raptor. Every little detail gets their undivided attention. They check and double-check the power source, cooling system, and beam control mechanisms. These crucial components are fine-tuned to unleash a jaw-dropping blow upon any unlucky adversary dumb enough to cross paths with this laser. The power source, the heart of the operation, gets some serious scrutiny. These scientists leave no room for doubt, ensuring a steady and reliable supply of power that lets the laser pack a serious punch. Think about the heat generated when this thing fires up. That's where the cooling system steps in, keeping things nice and chill. The scientists put their heads together to come up with genius ways to dissipate that crazy heat, ensuring the laser stays cool under pressure. Now, let's talk about precision. The beam control mechanisms are the secret sauce behind this laser's deadly accuracy. Those mirrors, lenses, and targeting systems get adjusted with surgical precision. It's all about nailing that perfect alignment, making sure the laser beam stays focused and rock solid. That means when it hits a target, it hits it hard, and there's no escape. But these scientists aren't just twiddling their thumbs. Oh no! They put the shield laser system through a series of intense tests, simulating all sorts of combat scenarios. They want to be sure this baby can handle anything thrown its way. The laser system needs to be as reliable as your favorite pair of sneakers, ready to unleash a devastating blow whenever the F-22 Raptor calls upon it. In this high-security lab, it's all about one thing: taking warfare to the next level. These scientists know that every tweak, every adjustment could be the difference between victory and defeat. Their dedication and hard work ensure that the F-22 Raptor, armed with the SHIELD laser system, is an unstoppable force in the skies. So when that laser fires up, you better believe it's going to pack a mind-blowing punch that leaves adversaries shaking in their boots. It is time to put the SHIELD laser to the test in a simulated combat scenario. The F-22 Raptor, armed with this groundbreaking weapon, takes to the skies. Its sensors detect incoming threats, and the SHIELD laser locks onto its target with deadly precision. And just like that, a burst of unstoppable energy engulfs the enemy aircraft as the SHIELD laser is unleashed. In a flash, the laser beam slices through the air, defying all traditional defenses in its path. It strikes with unimaginable force, crippling the enemy aircraft and sending it spiraling out of control. There's no escape as it hurtles toward the ground, defeated by the sheer might of the SHIELD laser. It's a game-changer, folks, a true testament to the raw power and precision of advanced laser warfare. Say goodbye to your adversaries because the future is here, and it's all about lasers. Military leaders convene in a high-level briefing room, their faces etched with anticipation and intrigue. The room hums with an air of excitement as they gather to discuss the awe-inspiring capabilities of the SHIELD laser system. Each leader brings their unique expertise and perspective, united by the common goal of harnessing this groundbreaking technology for the nation's defense. General Adams, a seasoned and respected figure, takes the lead, his commanding presence captivating the room. With a firm voice, he begins to address the assembly, saying, "The SHIELD laser has surpassed our wildest expectations. Its ability to engage multiple targets simultaneously, its minimal collateral damage, and its lightning-fast response time give us an unparalleled advantage on the battlefield." The F-22 Raptor, equipped with the SHIELD laser, becomes an unstoppable force. Its agility and the laser's precision turn the tide of battles with incredible efficiency. Air superiority is solidified, and ground targets are swiftly obliterated. Integrating the SHIELD laser into the F-22 Raptor simplifies the equation. Unmatched maneuverability plus laser power equals unstoppable aerial dominance. The laser's surgical precision ensures swift and decisive victories, making the F-22 Raptor armed with the SHIELD laser an uncomplicated yet unbeatable force on the battlefield. This powerful combination simplifies the path to victory, leaving adversaries in awe and securing a new era of aerial warfare. We're witnessing a true game-changer in air combat. The integration of laser weapons catapults the F-22 Raptor to the forefront of dominance. No adversary, no matter how advanced, stands a chance against the relentless onslaught of the laser. It's an unfair advantage, plain and simple. In this new era, the F-22 Raptor soars above the competition, wielding the power and speed of the laser with unmatched authority. Sky supremacy is no longer a debate, it's a given. With laser precision, the F-22 executes precise strikes that leave adversaries defenseless and trembling. As the F-22 Raptor squadron takes to the skies, equipped with the SHIELD laser, a new era of warfare unfolds. The combination of stealth, speed, and laser firepower propels the United States' aerial dominance to unparalleled heights. With each aircraft adorned with the advanced SHIELD laser, the F-22 Raptors become a force to be reckoned with. Their unmatched stealth capabilities allow them to fly undetected, while their blistering speed ensures they outmaneuver any adversary. And now, with the SHIELD laser, their power reaches new levels. As these mighty aircraft streak through the heavens, their laser beams strike with pinpoint accuracy, leaving no room for escape. The convergence of cutting-edge technology and strategic prowess enables the Raptors to swiftly neutralize threats, solidifying their position as unmatched aerial champions. This new era of warfare is marked by simplicity yet overwhelming effectiveness. The F-22 Raptor squadron, armed with the SHIELD laser, showcases the power of combining stealth, speed, and laser firepower. It represents a future where the skies are unequivocally dominated by these formidable aircraft, forever changing the landscape of aerial combat. The F-22 Raptor and the SHIELD laser, an extraordinary alliance born of technological innovation and military prowess. As the boundaries of warfare continue to expand, the journey of the F-22 Raptor and its integration of laser weapons is merely the beginning, heralding a future where the impossible becomes a reality. The unmistakable roar of the A-10 Warthog's engine sends shivers down the spines of its foes, while its robust armor and formidable weaponry can pierce enemy armored vehicles as if they were mere tin cans. The A-10's heavy armor makes it a tough nut to crack, allowing it to withstand enemy fire and continue its mission, ensuring that it can return safely to base even after taking a considerable amount of damage. With nearly half a century of dedicated service in the U.S. Air Force, this aircraft has become an enduring symbol of American air power. However, despite its age, the A-10 is far from retiring. In fact, it was slated for yet another upgrade, proving that this battle-tested vehicle is still very much in the game. Now, this upgrade is ready for testing, and some countries are shocked by the remarkable rebirth of the Warthog. Join us as we explore the reasons behind the Russia panic as the USAF tests the new Super A-10 Warthog. You might be wondering why the U.S. Air Force continues to rely on the A-10 Warthog, a venerable aircraft that took its first flight way back in 1976. After all, sleek and advanced fighters like the F-35 Lightning are still in service. Well, it's simply because the A-10 excels in the crucial role of providing close air support to ground forces. It's the go-to aircraft for hanging over the battlefield and supporting troops on the ground, a task that the F-35 isn't designed for. The A-10 Warthog stands out because it's purpose-built for this job. Sure, it might not be as elegant or graceful as the McDonnell Douglas F-15 Eagle or the F-16 Fighting Falcon, but it possesses a unique set of virtues that make it indispensable. The heart of this aircraft is its primary weapon, a 30mm automatic rotating Gatling-style gun known as the GAU-8A Avenger. The GAU-8A Avenger is one of the most potent aircraft guns in its class. First off, this beauty weighs nearly 2 American tons. Secondly, it boasts a jaw-dropping rate of fire, spitting out 3,900 rounds per minute. This means the Avenger can pierce armored vehicles at a distance of 1,312 yards, sending 65 rounds downrange every second. Not to mention, its accuracy is around 80% before the barrels start to overheat. This gun has earned itself the nickname the Burr because of its sheer power. Replacing the weapon would not only rob the A-10 of its charisma, but would also be a technically challenging and costly endeavor. However, the Avenger is not the A-10's sole armament. It can carry a variety of weapons on its 11 different hardpoints. There are 3 under the fuselage and 8 under the wings. This allows the Warthog to haul up to 7.93 tons of assorted weaponry. Its arsenal includes high-precision anti-tank missiles like the AGM-65A and AGM-65B Maverick, with a firing range of up to 17.4 miles, and the fire-and-forget homing capability. The A-10 can also pack a punch with rockets, high-precision, and conventional bombs. Designers even conjured up a guided high-precision bomb of the SDB or small-diameter bomb class, the GBU-39. This 250-pound bomb with a guidance system and wings allows 4 GBU-39S to be carried per pylon using the BRU-61A rack. With such weaponry, the A-10 can take on formidable targets, such as anti-aircraft missile systems like the Russian Tor M2 and Panzer S-1, all while staying safely out of their reach. But the A-10 Warthog isn't just about its hardware. The updated version of this legendary attack aircraft is set to be integrated with unmanned aerial vehicles, which will transmit target coordinates, adding a whole new layer of versatility. Moreover, the A-10 is renowned for its simple maintenance and doesn't demand special runways. These factors combine to make it an invaluable asset in modern warfare. In the Persian Gulf in 1991, something unexpected unfolded that caught the attention of military experts and international observers alike. That's where the A-10 Warthog made a name for itself, earning its stripes alongside the renowned F-15 fighter and the stealthy F-117 Nighthawk. As part of Operation Desert Storm, a whopping 144 of these combat vehicles were deployed, and the Warthog had a single primary mission. It was to hunt down enemy tanks, and it delivered impressive results. One of the standout features of the A-10 is its superb maneuverability at low altitudes, a quality that allowed it to deftly evade enemy threats. Coupled with excellent visibility from the cockpit and a relatively low flight speed, the A-10 proved itself adept at targeting even smaller objectives on its first pass. During Operation Desert Storm, this mighty aircraft managed to disable over 1,000 Iraqi tanks, around 2,000 other armored vehicles, 1,200 artillery pieces, and 2 helicopters. All this was accomplished with the loss of only 7 A-10s in combat, with approximately 15 others sustaining damage. The Warthog's durability was put on full display during this period. One of the Thunderbolts suffered severe damage to its wing, but still managed to return to base, a feat deemed impossible for most other aircraft. This goes to show the remarkable resilience built into the A-10's design. The A-10 Warthog wasn't content with just one shining moment in history. It made a return in Operation Iraqi Freedom, which unfolded from March to April 2003. In a harrowing air battle over Baghdad, one A-10 was dealt a devastating blow. Its hydraulic system failed, one engine was severely damaged, and the aircraft was riddled with hundreds of holes in the fuselage, wings, and plumage. Despite all these challenges, the pilot, Colonel Kim Nicole Reed Campbell, managed to navigate this wounded aircraft safely. This feat earned her a well-deserved accolade. The A-10's ability to return to base under such dire circumstances isn't merely due to luck. It's a result of careful aircraft design. Every control system within this beast features 3-layer redundant reserves, 2 115 or 200-volt 3-phase alternators, and an emergency source, a 34 ampere-hour battery with a 24-volt output. Moreover, an auxiliary power unit provides electricity when the engines aren't running, and ground power sources aren't accessible. What's more, parts of the cockpit and systems are shielded against rounds up to 23 millimeters, adding another layer of protection. Interestingly, the A-10 Warthog's engine placement in separate cells offers an additional safeguard against ground fire. At one point, the decision was made to replace the high-temperature turbofan bypass engines developed by General Electric with modern power plants that offer similar thrust, but come with lower fuel consumption and reduced weight. This enhances the aircraft's performance and efficiency. And remember that the A-10's unique design allows for the possibility of belly landings, which is a pragmatic approach to ensuring the aircraft's survivability. However, nations like Russia and China are actively developing advanced weaponry, not just to bolster their military might, but with a particular focus on posing a threat to the United States, which is undeniably viewed as their primary adversary. These countries have become adept at exporting their formidable weapons to numerous potential challengers of the U.S., effectively extending their influence across the globe. In this heightened era of geopolitical tensions and military innovation, ensuring the A-10 Warthog's relevance and effectiveness becomes crucial. To achieve this, a continuous process of integration and upgrading of countermeasures against these new threats is imperative. The A-10, known for its legendary tank-busting capabilities, needs to adapt to this newly dangerous environment. Now that the A-10 Thunderbolt has undergone some noteworthy upgrades, its capabilities have been enhanced, and its service life has been extended. One of the significant updates includes the introduction of new wings designed to endure an impressive 10,000 flight hours. This isn't just a facelift. It's a testament to the A-10's enduring presence in modern air warfare. But the enhancements don't stop at its wings. The A-10 has transitioned from its analog roots to a more modern digital battlefield. The first step in this evolution was the A-10C Precision Engagement Program, which introduced the hands-on throttle and stick, or HOTAS system. This technology is already familiar to pilots of modern fighter aircraft. With HOTAS, pilots can seamlessly control the plane without removing their hands from the control lever. Another exciting addition to the A-10 Warthog is multifunctional screens, displays on the pilot's helmet, and new optoelectronic containers and radars. The aircraft's multifunctional display may take a page from the F-16's book, complete with 2 displays as part of the Precision Engagement package. This means that the pilot can access critical information at a glance, increasing situational awareness. The A-10 is also set to receive a Link 16 connection, a significant upgrade that will facilitate more extensive and efficient data exchange. This feature is crucial for real-time communication and coordination during missions. Furthermore, the aircraft is now equipped with helmets featuring the BAE Systems Striker II HMD or helmet-mounted display, with integrated night vision and target tracking. These advances are part of the ongoing effort to keep the A-10 Warthog relevant in the ever-evolving landscape of modern warfare. But one of the most exciting updates to the A-10 is the addition of synthetic aperture radar, the SAR technology. This capability enhances the aircraft's ability to detail the surrounding area. The radar technology could include the Active Electronically Scanned Array, or ESA radar, the ANASQ-236 Dragon's Eye. ESA provides high-resolution imagery and can detect objects concealed underground, a powerful asset for ground support missions. It's important to note that the upgrades might seem like a considerable package, but it's actually a streamlined version of what was initially proposed. Even in this condensed form, the U.S. Air Force now boasts an A-10 that's more than just an aircraft with wings. It's a full-fledged flying bomb train. Apart from the Warthog, the only other aircraft built for close air support is the Sukhoi Su-25, a Russian creation. This aircraft started production in 1978, following a development trajectory similar to the A-10. The Soviet Air Force recognized the need for a low-altitude, highly survivable aircraft to complement its attack aircraft fleet. Prior to the Su-25, aircraft like the Su-17, Su-22, MiG-23BN, and MiG-27 had a single engine and lacked adequate armor, rendering them highly vulnerable to ground fire. The combat experience in Afghanistan highlighted the urgency for an aircraft with armor protection and two engines to ensure survivability. While the Su-25 is also categorized as an air support attack aircraft, it leans more towards being a multi-purpose attacker. It relies on a combination of higher cruising speeds, maneuverability, and ground cover to evade enemy fire and emerge unscathed. Delving into the design and payload aspects, the Su-25 is notably smaller and lighter, weighing in at 19.3 tons for takeoff compared to the A-10's 22.7 tons. The smaller size of the Su-25 gives it an advantage in cockpit protection. It carries a substantial amount of titanium armor on board, up to 1.2 tons, with armor thickness ranging from 10 to 25 millimeters. In contrast, the A-10's cockpit is safeguarded by nearly 4 centimeters thick titanium armor, weighing over 0.5 tons. However, the Su-25 carries a smaller payload, around 4.4 tons, in comparison to the A-10's 7.99 tons. The A-10's superior payload capacity can be attributed to its larger size and weight. Yet the difference becomes less significant when you consider the number of hardpoints and equipment on board. When it comes to armament and power, both aircraft are equipped with an array of weaponry that strikes fear into the hearts of ground forces. The Su-25 is equipped with a GSH-32 gun, lighter than the A-10's weaponry, but with an impressive firing rate of 3,000 revolutions per minute. This gun proves more than adequate for its ground attack missions. The Su-25's arsenal includes rockets, bombs, and surface-to-air missiles, such as the KH-23, KH-25, and KH-29. It should be noted that the Su-25 SM variant can also carry R-73 air-to-air missiles. Now, the engines and performance are where these aircraft diverge significantly. The A-10 is powered by two TF-34 engines, which provide it with a robust performance. These engines, while powerful, are exposed and vulnerable to ground fire. In contrast, the Su-25 features an R-95 engine nestled within the fuselage, boasting an added layer of protection from titanium armor. This feature enhances the Su-25's survivability against ground fire. Additionally, the Su-25's engine is multi-fuel, capable of running on various types of fuel, whereas the A-10's engine is limited to jet fuel. The Su-25 also outpaces the A-10 with a top speed of 590 miles per hour compared to the A-10's 437 miles per hour. However, it's essential to consider the operational range. The Su-25 has a shorter operational range of just 307.5 miles, only about half of the A-10's 640 miles. To extend its range, the aircraft can carry extra fuel externally, but this does come at the cost of reduced payload capacity. Takeoff distance is another factor to consider. The Su-25 requires a mere 656 yards of takeoff distance, while the A-10 necessitates 1312 yards. This makes the Su-25 more versatile and capable of taking off from unpaved runways and aircraft carriers. When it comes to survivability, the A-10 has a slight edge. The horizontal stabilizer shields its engines from ground fire, and the aircraft can fly at higher altitudes. Reports indicate that the deployment losses for both aircraft were comparable in conflicts like Afghanistan and Syria. For instance, in Afghanistan, it was reported that around 22 Russian Su-25 aircraft were downed during an 8-year deployment period, while no A-10s were shot down during an 18-year deployment in the region. In Syria, one Russian Su-25 was reportedly downed during a 3-plus-year deployment, while no A-10s were shot down during a 4-plus-year deployment in the region. These facts indicate that while the A-10 may be better suited for certain conditions, such as those seen in Ukraine where dogfights are rare, and the Su-25's low-altitude missions are at high risk of being targeted by man-portable air defense systems or MANPADS, each aircraft has its strengths. With the new upgrades the Warthog has undergone, though, the Su-25 may not stand much of a chance beside it anymore, a fact that caused Russia to panic. Funny enough, beyond the U-25, another fighter jet is competing with the A-10 Warthog, which is among the U.S. fighter jets. In 2014, a momentous clash of interests took center stage in Congress, involving the future of the A-10 Warthog. At that time, the U.S. Air Force presented a seemingly stark perspective. They claimed that the A-10 had become obsolete on the modern battlefield and should be retired. The reasoning was to allocate manpower elsewhere and free up a significant budget of $4.2 billion for the development and deployment of the F-35 Lightning II. The aircraft intended to succeed the Warthog. The U.S. Congress later pitted the A-10 Warthog and the F-35 Lightning II against each other in a battle for supremacy in the realm of close air support missions. This competition wasn't your typical face-off. It was a fly-off, an aviation showdown designed to determine which of these aircraft deserved to be the go-to choice for the U.S. Air Force's close air support operations. However, this fly-off, which was meant to be a decisive debate settler, quickly took a different turn. Instead of being a transparent and impartial assessment, there were murmurs that the Air Force might be orchestrating the contest in a way that favored the F-35 over the A-10. Moreover, secrecy shrouded this event, leaving many with unanswered questions. As it turned out, the fly-off didn't carry the weight one might have expected. The intriguing aspect was that specs and capabilities don't lie despite the controversy and secrecy. One well-known specification of the F-35 is its sleek design, engineered to cut through the air easily. Its high-tech gadgetry and advanced capabilities make it a marvel of modern engineering. However, the flip side of this sophisticated design is that the F-35 struggles to match the A-10 when it comes to flying low and slow in close air support missions. The A-10 is renowned for its ability to loiter for extended periods at low altitudes, flying so close to the ground that it requires a titanium bathtub-like belly to absorb the ground fire it inevitably draws from troops on the battlefield. This level of proximity to the action is almost unmatched. However, the Air Force's priority isn't to elevate the A-10's strengths. Instead, they seem more inclined to bring the F-35 up to speed. Investments amounting to a staggering $400 billion have poured into the development of the F-35, making it the most expensive weapons program in the Pentagon's history. Understandably, the Air Force intends to maximize its utilization, aiming for it to serve as a top-of-the-line fighter and a multi-purpose asset. The significance of the A-10's continued service is also underscored by voices within the military establishment, though. General James Holmes, the Deputy Chief of Staff for Strategic Plans and Requirements, emphasizes the need to strike a balance when considering aircraft options. It's not just about finding a replacement. It's about identifying the sweet spot that combines the available resources with the unique capabilities that the A-10 Warthog has consistently brought to the battlefield. This barrage of the A-10 upgrades addressed the Air Force's concerns regarding the Warthog's survivability significantly, cementing its position as a stalwart in close air support missions. With both the A-10 and F-35 on the same team, the Air Force's focus finally shifted towards outfitting the Warthog with fifth-generation technology. Ultimately, the A-10 Warthog is a powerful reminder of a fighter's enduring capabilities when it's prioritized and continuously updated. Its ability to keep up with the times and remain a formidable force on the battlefield showcases the remarkable flexibility and resilience of military aircraft designed for a specific purpose but capable of evolving to meet new challenges. The UK has faced its fair share of challenges on its journey to maintain its status as a Tier 1 military power. The Royal Air Force confronted an array of strategic threats, all while dealing with resource limitations and various other hurdles. These challenges have occasionally pushed Britain to reevaluate its strategies and invest in advancing its aircraft technology. But now, they've made a remarkable comeback with an invention that promises to revolutionize aerial warfare. This extraordinary fighter jet is brimming with cutting-edge weaponry and state-of-the-art systems, propelling it to the forefront of sixth-generation fighter aircraft. With this innovation, even the enigmatic American UFO fighter jet takes a backseat. The UK's strategic collaborations with international partners has successfully brought to life one of the most ingenious and awe-inspiring aircraft the world has ever seen. Join us as we delve into how the world is shocked. The new British fighter jet surpasses the UFO aircraft. The emergence of a sixth-generation European fighter jet is nothing short of remarkable, given that Europe has predominantly relied on fourth-generation fighters, while the US and China have already ventured into fifth-generation aircraft. The Eurofighter Typhoon used to be reliable. It was recognized as the best fighter jet within the European Union. With a top speed of 1,500 mph, a soaring flight altitude of over 50,500 feet, an extensive array of weaponry and dependable avionics, it has served well. However, even such a formidable fighter must take a back seat, as it was developed over 25 years ago. So, it's high time for a technological leap forward, and the success of a fighter jet largely depends on the expertise of its developers. Thankfully, this new project, called the Tempest Project, has assembled a team of military specialists from various countries, including the UK, Italy, Switzerland, and Germany, to collaborate on this groundbreaking endeavor. BAE Systems and Rolls-Royce are just a glimpse into the cooperative development approach. It's a practical strategy, as only a few EU countries can afford to individually create a new generation fighter. Moreover, many nations lack the necessary technical infrastructure. The Tempest project demonstrates that by combining efforts, knowledge, and budget, it's possible to create an aircraft that can outshine the competition. One notable feature of the Tempest is its variable wing shape, which can be adapted to suit different conditions and tasks, offering enhanced speed and maneuverability. Equally crucial is the engine, where Rolls-Royce excels. Despite the complex nature of hypersonic engines, the Tempest engine overcomes challenges, including cooling components at extreme temperatures. This powerful engine propels the fighter jet to an impressive speed of 1,860 mph, with 2 flight modes and a hydrogen tank for short bursts of flight at 2,800 mph. Rolls-Royce engineers are presently conducting aerodynamic tests on the engine, using innovative manufacturing processes to create a unique air duct. This design aims to slow down supersonic airflow to subsonic speeds, maximizing stealth and fuel efficiency. With such an engine, the Tempest can outpace the American NZAD fighter, which operates at a top speed of 2,200 mph, setting the stage for potential victories. Moreover, the UK's laser-directed energy program, led by missile systems manufacturer MBDA, has already initiated tests on new laser weapons. This collaborative effort involves the UK Ministry of Industry, UK Ministry of Defence, MBDA, and Leonardo. all companies deeply involved in the Tempest project. The laser system, capable of both offensive and defensive operations, delivers a staggering 300 kilobars of power. It harnesses infrared radiation directed at the enemy, heating their materials to thousands of degrees. This innovative weapon poses a grave threat to various vehicles, as it causes shells to ignite and detonate, tearing the target from the inside due to the intense heat. With this formidable laser cannon and its remarkable speed, the Tempest can infiltrate enemy bases and obliterate key positions with remarkable precision. And if you're thinking of taking the fight to the Tempest, think again. It operates at an altitude exceeding 65,500 feet, a height largely beyond the reach of most modern air defense systems. It also sports a modern stealth skin, a significant advancement from older fighters. Unlike previous models, where radar-reflecting coatings were employed, the Tempest uses an innovative composite material. This material is not only durable and lightweight, but also incredibly effective at evading radar detection. The Tempest indeed brings several fascinating features to the table. To further bolster its radar-defying abilities, the Tempest incorporates a radar jamming system. This system emits precisely tuned waves that disrupt enemy radar, making it challenging for adversaries to pinpoint the aircraft's location. Moreover, BAE Systems, one of the leading companies involved in the Tempest project, has announced the implementation of new software for safety-critical systems, employing automatic coding. This software approach not only safeguards the fighter from remote hacking attempts, but also shields it against interference generators. This comprehensive software approach also enables the rapid evaluation of flight control system performance during complex maneuvers. The use of simulators provides crucial insights into how the aircraft will perform, long before its first flight. In fact, Royal Air Force pilots have already accumulated more than 150 hours of flight experience using the demonstration aircraft in a specially designed simulator. This ensures that when the Tempest is ready for deployment, it will be operated by well-trained military personnel. However, one intriguing aspect of the Tempest's design is the integration of unmanned systems, presenting a paradigm shift in military aviation. The Tempest incorporates three types of unmanned systems. Firstly, it employs artificial intelligence within its onboard computer, enabling remote control and potentially autonomous operation. Imagine an unmanned fighter jet armed with a lethal laser weapon patrolling the skies. The second unmanned system is a surveillance drone that works in line with the Tempest, facilitating the collection of intelligence over a vast area equivalent to more than 250 football fields. This capability enhances the fighter's situational awareness and decision-making abilities. The third system, an augmented reality helmet, plays a crucial role during intense aerial battles. Given the Tempest's incredible speed, a pilot may struggle to react effectively to rapidly changing situations. The augmented reality helmet bridges this gap by transmitting information from the fighter's sensors directly to the pilot's head. This real-time connection fuses the pilot's cognitive abilities with the aircraft's systems, creating a seamless integration. Moreover, the helmet's sensors can monitor the pilot's brain signals and other physiological data. Over time, this smart helmet accumulates a unique psychometric database for each pilot, enabling the onboard computer to intervene when necessary. With the mesmerizing features and capabilities of this jet, people have concluded that it's much better than the UFO aircraft that is rumored to have been created by the U.S. Air Force. This aircraft, known as Aurora, has allegedly been sighted only in the U.S. and the U.K. On November 29, 2014, residents in the southern parts of the UK and the east coast of the United States were startled by a series of loud and mysterious sounds. A recording of these perplexing noises, captured by a London resident using a cell phone, quickly made its way to the internet. To this day, the exact source of these sounds remains a mystery, leading to various speculations. However, one of the most intriguing theories was the flight of the Aurora, the mysterious project linked to the U.S. Air Force. Media reports suggested that witnesses had frequently observed peculiar flying machines in the shape of massive black wings in the sky. While some thought of them as UFOs, others dismissed the notion of alien involvement, attributing the sightings to a top-secret U.S. aircraft. The TR-3B Black Manta aircraft is a top-secret component of the Aurora project. Some of its technical features have been disclosed. This aircraft is said to be equipped with a combined engine featuring turbojet and ramjet circuits. Its hypersonic capabilities would be enabled by pulsating combustion of fuel, providing speeds 10 to 15 times faster than the speed of sound, at altitudes ranging from 35 to 36 kilometers above the ground. Most remarkably, the TR-3B Black Manta is rumored to incorporate an anti-gravity device capable of reducing its massive weight to nearly nothing, although this would require a substantial amount of energy. To meet these energy demands, a compact nuclear reactor is rumored to be on board. While we have no data on the aircraft's aerodynamics, some say it bears a resemblance to the infamous F-117, despite its speed of 37,000 km per hour and a ceiling of 27 kilometers. The notion of anti-gravity technology might sound like pure fantasy to many. After all, gravity is considered a fundamental property of any material body. However, it's worth remembering that in the 19th century, submarines were also regarded as science fiction, so we may still have a lot of discoveries to make. Even with the remarkable abilities of the Black Manta, though, the Tempest surpasses the mysterious UFO aircraft in terms of general performance. Comparisons between the Tempest and the American NGAD are inevitable as well, as they share several key features. Both aircraft are AI-controlled, armed with powerful lasers, and excel in radar-evading capabilities. While NGAD is primarily a U.S. initiative, Colonel Metrolease expressed a willingness to welcome the UK's input on sixth-generation development and deployment. However, the specifics of this potential collaboration remain uncertain, particularly concerning the core components of the NGAD and the UK's Tempest program. Also, what distinguishes the British Tempest is its focus on ease of modernization. The aircraft is designed to accommodate swift upgrades, much like downloading an app to a smartphone. This future-ready approach ensures that the Tempest can quickly adapt to specific mission requirements. Pilots can access the necessary settings with ease, allowing them to operate the aircraft in autopilot mode, confident that it's optimized for even the most challenging tasks. While the NGAD program has had a demonstrator in flight since late 2020, it remains concealed from public view. By most accounts, it's expected to feature a heavy, tailless, stealthy design that diverges from traditional fighter aircraft. Key attributes of the design are likely to include long-range capabilities, high payload capacity, advanced sensor fusion, situational awareness, connectivity through advanced networking, and a high degree of stealth. The focus here is on survivability and range, though it's worth noting that these advanced platforms come with significant costs, potentially reaching multiple hundreds of millions of dollars per unit. An intriguing aspect of NGAD's manned fighter component is adaptability. There is evidence to suggest that the U.S. Air Force is considering two different configurations of a single design. One configuration would be optimized for European operations, while the other would be tailored for long-range, long-endurance missions in the Pacific. The latter configuration appears to be the primary focus. Going back to the Tempest, we know it's also designed as a sixth-generation fighter. It is characterized by a higher level of automation and cutting-edge technologies. These advancements extend to communication systems and countermeasures against enemy electronic warfare, further cementing its status as a formidable asset in the world of military aviation. However, before the advent of the Tempest, some cutting-edge aircraft have ruled the skies, and some of them are still ruling. When it comes to exceptional fighter jets like this, the F-22 Raptor unquestionably earns its place in the spotlight. It's a marvel of technological progress, boasting a maximum flight altitude of 62,000 feet and speeds reaching a staggering 1,500 mph. Notably, the F-22 Raptor was adopted and tested at an accelerated pace compared to its international counterparts. While its performance is impressive, the F-22 Raptor also holds the distinction of being the most expensive combat aircraft in aviation history, with a price tag of $146 million, excluding development costs. The aircraft's design places a strong emphasis on survivability, with a cockpit crafted from polycarbonate glass, featuring a special radio wave scattering coating. This design not only enhances radar evasion, but also fortifies the aircraft against high-explosive munitions. A standout feature of the fighter jet is its radar system, consisting of 2,000 elements. This sophisticated antenna can detect targets at a remarkable distance of 140 miles and cruise missiles from 77 miles away, setting a high bar for fighter jets. Originally designed to secure air supremacy, the F-22 Raptor excels in air-to-air combat, making it a formidable adversary for modern aircraft. However, it's not as adept at engaging ground targets. Interestingly, the recent unveiling of a new concept model of the Tempest at the Farnborough International Air Show showcased a design with striking resemblances to the U.S. F-22 Raptor, with elements reminiscent of the Northrop YF-23, a competitor of the F-22. Now, let's shift our focus to another impressive contender, the F-35 Lightning II. This fifth-generation fighter jet stands out as a technical marvel, equipped with engines that propel it to speeds of 1,200 mph. The unique feature here is the ability to switch to vertical thrust mode, allowing the F-35 to operate without a traditional landing strip. This capability led to the F-35 becoming the sole fighter used on aircraft carriers, an impressive feat considering it isn't a deck-based fighter. Another pivotal factor contributing to the F-35's popularity is its remarkable invisibility. As detection technologies continue to evolve, invisibility to radar has become a paramount concern in aviation. The F-35's design hones this aspect to perfection, incorporating reflective plating, a low-profile shape, and a technology blocking system that renders it elusive to radar detection. Moreover, the F-35 is equipped with a remarkable pilot's helmet that features a built-in display, providing vital combat information directly in the pilot's line of sight. This feature proves invaluable during intense aerial combat scenarios. The F-35 really leaves no room for doubt. It's armed with ASRAAM-guided cruise missiles for larger air targets, capable of accelerating to speeds exceeding 2,500 mph. For smaller adversaries, a 4-barreled 25mm cannon swiftly turns them into a sieve. When it comes to ground targets, the AGM-158 cruise missile, weighing a ton and designed for precision strikes on well-protected objectives, is the weapon of choice. This missile is known to excel even in adverse weather conditions, but there's more to the F-35's arsenal. It boasts HARM anti-radar missiles, effective at detecting and destroying enemy radars. Additionally, the aircraft has the capacity to carry cluster and nuclear bombs, underscoring its versatility. What's even more exciting is the potential addition of real laser weaponry to the F-35's arsenal. Engineers are actively developing an onboard control system that leverages artificial intelligence with self-learning capabilities. This approach redefines the pilot's role, transforming them into key decision-makers while delegating numerous tasks to automation, making the F-35 an aviation complex of unparalleled sophistication. Also, we should explore some worthy adversaries that, surprisingly, belong to the previous, fourth generation of fighters. One such aircraft is the F-16 Fighting Falcon, a venerable jet with over 10 main varieties and an equal number of local versions. The most modern iteration is the F-16V, boasting several remarkable features that have contributed to its acclaim. With a length of 49 feet and a wingspan of 31 feet, the F-16V is highly maneuverable and compact, making it ideal for swift and surprise attacks. What's even more impressive is its ability to carry up to 21 tons of payload, including homing anti-tank missiles, air-to-air missiles, and a radar jamming system, a comprehensive arsenal capable of dealing with various threats. While its top speed of 930 mph is slightly lower than the F-35's, the F-16V possesses a numerical advantage with over 4,600 units produced compared to the 900 F-35s currently in operation. This numerical superiority holds strategic significance, allowing for a formidable swarm capable of overwhelming technologically advanced adversaries. Over the years, developers realized that the F-16's potential exceeded its current capabilities. This led to enhancements in stealth, avionics, controls, structural strength, and armament. The incorporation of millions of microparticles of a special substance on the aircraft's surface significantly bolsters its radar evasion capabilities. There's also the FA-18, a versatile fourth-generation fighter jet that serves as both a fighter and an attack aircraft. The Super Hornet, which took to the skies in 1995, set new standards in multiple aspects, including layout, electronic equipment, radar capabilities, and the use of radar countermeasures. Its radar, with a remarkable range of up to 90 miles, marked a historic achievement. Moreover, the FA-18 was among the first to employ a system designed to counter enemy radar. With a focus on versatility, the Navy sought to enhance the Super Hornet's range, survivability, and armament. This comprehensive approach is driven by the need for a versatile aircraft on aircraft carriers. As a result, the Super Hornet stands as a jack-of-all-trades, capable of fulfilling a wide range of missions. It can carry a dozen AIM-120 air-to-air missiles, ideal for supersonic engagements, and AGM-158C stealth missiles designed for anti-ship operations. High-precision bombing with up to 10 bombs in a single flight is also well within its capabilities. Surprisingly, the FA-18 is even equipped to function as an air tanker. Its resilience is further demonstrated by its adaptation to the rigorous demands of catapult launches, hard landings on aircraft carriers, and exposure to salt water. The Super Hornet's prowess and versatility are unquestionable, yet it's intriguing that it hasn't reached the same level of popularity as the F-16, despite a lower price tag of $53 million compared to the F-16's $57 million excluding weapons. While both the F-16 Fighting Falcon and the FA-18 Super Hornet are undeniably impressive in their own right, a new player is poised to redefine the aviation landscape. Beyond the Tempest and NGAD, there is also the Dark Star, a sixth-generation fighter jet currently in development, with capabilities that push the boundaries of what's possible. The Dark Star's specifications are truly awe-inspiring. It can achieve speeds of 4,300 mph, operate combat and reconnaissance drones, utilize the most powerful laser weapons, employ advanced stealth technologies for invisibility, and maintain continuous flight thanks to artificial intelligence control. Although it remains in development, it is already a strong contender for the title of the best fighter in aviation history. But will the Tempest allow that to happen? We can only anticipate how things will play out in the coming years. In the world of military aviation, there's a secret realm that goes way beyond typical aircraft, hidden from the public eye. Up there, above the clouds, these mysterious aircraft baffle us. Aviation companies in the US have kept themselves busy, trying their hands on different projects that have left people curious and wondering, and we will be thrashing the questions everyone is asking about these strange aircraft. Join us as we unravel the mystery behind the seemingly otherworldly jets in our skies and the insane new UFO airplane US scientists recently announced. Antelope Valley has always been a hub for military bases and government contractors in the US defense industry. Stretching between Palmdale and Lancaster, California, This 300-acre area houses the 42nd Plan of the U.S. Air Force, along with Skunk Works, Northrop Grumman, Boeing, and NASA's Armstrong Flight Research Center. Heading north, you'll find Edwards Air Force Base, and a bit farther lies the U.S. Naval Base of China Lake. Let's not forget the intriguing Groom Lake area, which is practically a magnet for anyone seeking encounters with classified or extraterrestrial phenomena. Among these enigmatic artifacts, there's the TR-3A Black Manta, a hypersonic reconnaissance aircraft supposedly developed by the U.S. Air Force in collaboration with Northrop, the people who brought us the legendary B-2 Spirit stealth bomber. Some reports also suggest the Astra Aurora and the SR-91 project as potential successors to the iconic Lockheed SR-71 Blackbird strategic reconnaissance aircraft. However, it's more likely that the TR-3A served as a precursor to the Aurora project. Unlike the Aurora, the TR-3A didn't have conspicuous protruding wings. Instead, its shape was crafted with exaggerated stealth features, transforming it into a flawless black triangle. It also had all its surfaces coated with a special polymer that had radio observation capabilities. This polymer, combined with advanced electronic recognition systems, allowed the aircraft to manipulate its radar appearance. It could mimic the look of a cylindrical or even a miniature flying object. The core mystery of this plane revolved around its power source. It was rumored to employ a high-pressure mercury-based system, accelerated by nuclear energy. This setup generated plasma, creating an almost complete anti-gravity field around the craft, reducing its weight by a staggering 89%. Some experts have described this setup in detail, explaining that it incorporated a circular plasma-filled accelerator ring known as a magnetic field disruptor. This technology was leaps ahead of anything we could imagine at the time. The TR-3A mercury-based plasma was pressurized to a mind-boggling 250,000 atmospheres at a chilling temperature of 150 Kelvin. This plasma was then accelerated to a dizzying 50,000 revolutions per minute, creating a superconducting plasma that effectively manipulated gravity. The Black Manta seemed to disregard the laws of physics. To control its movement, the TR-3A had conventional thrusters at its ends, allowing it to maneuver swiftly in 3 dimensions at speeds of up to Mach 9. The main limitation of this aircraft was, unsurprisingly, the physical limits of the pilot. It's hard to argue with that. What's truly fascinating is that this triangular wonder wasn't just seen in the USA. In the early 1990s, witnesses in Belgium captured photographs of a mysterious object with 4 bright lights, often mistaken for a UFO. But in all likelihood, it was the Black Manta. Some evidence even suggests that these reconnaissance craft were used during the Gulf War to provide laser targeting for Lockheed F-117 Nighthawk bombers, aiding them in delivering laser-guided bombs with precision. Some also argued that this mysterious aircraft served as a research project, essentially a precursor to the V-2 Spirit. It played the role of a testing ground for aerodynamic solutions, intending to enhance the future bomber's performance. It's worth noting that both these aircraft were created by Northrop, but the investment in Black Manta was substantial, even when compared to the tremendously expensive Spirits, which cost more than $3 billion at the time. The TR-3A is credited with a slew of technologies, some of which even today seem right on the cusp of science fiction. These include super-powerful long-range combat lasers, the ability to manipulate climate conditions within a specific radius, and the use of extraterrestrial technologies at the core of its design, acquired by authorities following UFO incidents around the planet. As we've mentioned before, much of what's said today can sound pretty anti-scientific. While the TR-3A story revolves around a grounded, stealthy reconnaissance platform designed to work alongside the F-117, things take a bizarre turn when we delve into the TR-3B's claims. Unlike its turbojet-powered counterpart, the TR-3B is rumored to be powered by a reverse-engineered anti-gravity drive supposedly salvaged from a crashed alien spacecraft. This is where reports of unidentified aerial phenomena, UAP, executing seemingly impossible aerial maneuvers intersect with stories of very real aircraft. Many narratives about the development of the TR-3B center around Operation Paperclip. This program involved the United States absorbing over 1,500 German scientists and engineers at the end of World War II to continue working on various defense technologies. Myths surrounding advanced Nazi technologies emerged in the post-war years, and over time, the folklore surrounding this anti-gravity platform became entangled with claims of Wunderwaffe. Wunderwaffe is a German term that translates to wonder weapon. During World War II, Nazi Germany's propaganda ministry used this term to describe a range of revolutionary superweapons. However, it's crucial to note that the majority of these weapons remained in the prototype stage. They either never made it to the battlefield or, if they did, arrived too late or in such limited numbers that they had little to no military impact. Despite how outlandish the claims of the TR-3B might initially seem, though, there is some evidence that supports certain aspects of them. For instance, the anti-gravity drive that believers say powers the TR-3B would necessitate an immense power source, far beyond what current aviation engines can produce. However, Lockheed Martin does hold a patent for containerized cold fusion reactors that they claim could be compact enough to fit inside an F-16's fuselage. But there's more to this story. The most extreme and, some might say, unbelievable aspects of the TR-3B might find an explanation in the work of a certain aerospace engineer who is said to be currently working for the U.S. Space Force. In 2020, the U.S. Navy made headlines by filing a series of remarkably unconventional patents. These patents covered an array of topics, ranging from gravitational wave generators to space-time modification weapons, and they all had one common denominator: Dr. Salvatore Cesar Pais. Dr. Pais has quite an intriguing resume. According to his official biography, he has worked as a NASA Graduate Research Fellow, an Advanced Concepts Analyst with Northrop Grumman, and with the Department of the Navy Strategic Systems Program. As of recent reports, he's now part of the U.S. Space Force. As of now, it's confirmed that the Navy has invested a minimum of $466,000 in advancing Dr. Pais's work since 2017. A substantial portion of this work has been made accessible to the public through 3 patents filed by the Navy. The first patent, titled Craft Using an Inertial Mass Reduction Device, dates back to 2016. What sets Pais's patents apart as highly unusual is their public accessibility. Since the Invention Secrecy Act of 1951, the U.S. military has typically kept patents hidden from public view. However, the patents don't provide an explanation for the United States allegedly possessing this technology back in the 1990s. Furthermore, there's no concrete evidence to suggest that they have translated into tangible technology even to this day. Proponents of these ideas argue that the United States has been diligently studying these systems for decades, though, and they might be unveiling their efforts through patents as a preemptive measure against foreign programs, such as China's, which is believed to be on the verge of a significant breakthrough or some form of public disclosure. While Salvatore Pais's work may hold the potential for groundbreaking results, for now, there's limited evidence to substantiate his claims or confirm the functionality of his patents. Within the scientific community, he certainly has his share of skeptics. Speaking of other famous American stealth aircraft, one that stands out is the Northrop Grumman B-2 Spirit. However, there's a crucial piece of the puzzle without which the B-2 Spirit might have remained just a concept on paper. That's the Lockheed F-117 Nighthawk. The development of this aircraft was wrapped in such tight secrecy that even some high-ranking Pentagon officials were in the dark about its existence. The mystique around the F-117 Nighthawk led to intriguing tales. Due to the extremely limited knowledge about the plane and the accounts of witnesses who spotted peculiar shapes in the sky, the legend of the F-19 stealth fighter was born. It was thought to be a non-existent 5th-generation aircraft, and it even made its way into model kits like the Revel monogram. Names like Hillary and Chester are associated with these kits, supposedly created based on photographs of the plane straight from Area 51. Things got even more interesting in the summer of 1986 when a real Nighthawk crashed in California. Many media outlets used the F-19 model from hobby stores to depict what the downed aircraft might look like. This, of course, fueled public fascination with the F-19 legend. Curiously, after these incidents, One member of the House of Representatives, Ron Wyden, decided to question Lockheed's leaders about why an aircraft so shrouded in secrecy, to the point that even congressmen were unaware of it, was being widely sold as a model airplane. When the F-117 was finally unveiled in the fall of 1988, any notion that it was the same as the F-19 quickly faded. It's believed that the choice of the misleading designation F-117, where F implies fighter, was deliberate. This was done to conceal the true purpose of the future American aircraft from the USSR after the F-117's combat debut became public. Following its public debut, the F-117 wasted no time proving its capabilities. During Operation Desert Storm, these stealth aircraft racked up over 6,900 flight hours, carried out 1,300 sorties, and obliterated more than 1,600 targets. The sole F-117 lost in combat occurred over Serbia in the spring of 1999 during the NATO campaign in Kosovo. Enemy radar detected the aircraft when it opened its bomb bay doors to release its payload. Fortunately, the pilot ejected safely and was rescued. And today, you can see the Nighthawk's cockpit canopy, helmet, and ejection seat at the War Museum in Belgrade. What's particularly intriguing is that after the F-117 crash in the People's Republic of China, they approached the Yugoslav government to request access to the wreckage. This granted them access to the guidance systems and various heat-resistant components of the engine nozzle. According to the former head of Croatia's military headquarters, agents from the People's Republic of China actively searched the crash site where the Americans had been. People even resorted to purchasing plane parts from local farmers in their quest to uncover the secrets of stealth technology. Another stealthy gadget is the enigmatic Beast of Kandahar. This drone, known as the Sentinel RQ-170 UAV, or simply the Wraith, was developed by Lockheed Martin's Skunk Works division for the U.S. Air Force and the CIA. Despite these drones actively patrolling the world's hotspots and gathering classified intel, there remains a dearth of detailed information about them, so much so that the U.S. Air Force refrains from confirming much. The RQ-170 Sentinel, essentially a single-engine flying wing, had a heftier takeoff weight compared to the RQ-3 Darkstar, tipping the scales at 8,500 pounds. Interestingly, it didn't sport the typical features of a stealth aircraft, like the zigzag-edged landing gear, sharp leading edges, and exposed wing exhaust. Some publications argued that these peculiarities were intentional, a choice made by designers due to uncertainties surrounding the operational losses linked to its single-engine design and the desire to avoid revealing advanced stealth technologies. Another detail that caught enthusiasts' attention was its light gray color, suggesting a potential maximum altitude ceiling of up to 50,000 feet. At higher altitudes, the U.S. typically preferred darker colors to enhance stealth. In 2005, this UAV was deployed to Afghanistan, where one of them was spotted at Kandahar International Airport, earning it the moniker Beast of Kandahar. In 2011, at least one of these drones witnessed the assault on Osama bin Laden's compound during Operation Neptune Spear, leading to the elimination of the al-Qaeda founder. During the same year, Iranian forces managed to capture one of these elusive machines when it strayed about 140 miles from the Iranian border, likely on a reconnaissance mission regarding Iran's nuclear activities. Iran claimed it could hack the drone while it was in the air, but U.S. officials dismissed this assertion, attributing the capture to jamming the drone's signal, which led it to land on its own due to an internal problem with its takeoff and landing control system. This incident marked a significant episode in the ongoing intrigue surrounding these stealthy machines. In the winter of 2021, an American photographer also managed to capture one of these drones located to the south of Edwards Air Force Base. Shortly after, it was spotted in Guam, sparking speculation about possible upgrades, like enhanced sensors and synthetic aperture radar for operations over the South China Sea. The most recent mention of the UAV's activities falls between September 2022 and February 2023, when the RQ-170 was sighted near Russia during the tense Ukrainian conflict. These drones appeared to be conducting reconnaissance over the Black Sea, and they will likely continue to monitor the ongoing hostilities. Now we can move on to the Bird of Prey, an intriguing aircraft that was a collaborative effort between McDonnell Douglas and Boeing, dating back to the 1990s. It earned its nickname, the Bird of Prey, because of its uncanny resemblance to the Klingon spaceship from the iconic Star Trek series. This aircraft is another Black project, involving stealth. The Phantom Works, an internal division of Boeing responsible for the military's most secretive prototypes, was at the helm of the endeavor. A quick look at the resume of Division Vice President Alan Weichman reveals his previous involvement with Lockheed and their famous F-117 Nighthawk stealth aircraft, along with the Sea Shadow stealth ship. Given this background, it's not surprising that the Bird of Prey project fell under this team's purview. The Bird of Prey's standout feature was its minimal radar profile. This was achieved through a clever aerodynamic design that concealed any gaps in the aircraft. Flexible casings concealed these gaps, while the cockpit, landing gear, wings, and fuselage were meticulously aligned to ensure that no element protruded, contributing to its exceptional stealth capabilities. Furthermore, the aircraft's engine air inlet was cleverly concealed from the front view. The engine itself was nestled deep within the fuselage, disguised by a streamlined canopy. Even the engine air inlet duct and exhaust system were revamped to minimize the device's acoustic signature. Weichmann's team approached this challenge in a revolutionary manner. Instead of the traditional method of developing physical prototypes, testing them, making adjustments, and then creating new prototypes, they employed computer-assisted design. They harnessed the full power of ERA's cutting-edge computing capabilities to model performance. This innovative approach allowed them to produce component prototypes that closely resembled the final product, a departure from earlier methodologies. Before testing commenced, many skeptics doubted whether this seemingly alien aircraft could even take off. The chief pilot, Rudy Haug, famously crafted a paper model resembling the Bird of Prey, and to everyone's surprise, this model gracefully flipped onto its back before soaring into the air. In 1996, Haug managed to successfully lift the actual Bird of Prey into the sky. Its top speed of 300 miles per hour and ceiling of 20,000 feet didn't set any records, but that wasn't the goal. Boeing specialists didn't aim to outperform the fighter jets of their time. Instead, they set out to prove that it was possible to create a cost-effective stealth aircraft. The project's price tag came in at around $67 million, which remarkably is even less than the current cost of the F-35 Lightning II. This achievement by the Bird of Prey reshaped the rules of aircraft design and construction, sparking a transformative shift in the industry. However, you won't find the Bird of Prey hidden away in the depths of Area 51 today. Instead, you can catch a glimpse of it at the National Museum of the U.S. Air Force in Wright-Patterson, Ohio. Moving back to the Black Triangle aircraft, let's talk about the Aurora, which was a bit different from the TR-3A. The enigmatic aircraft is estimated to reach a top altitude of 135,000 feet, cruising around 90,000 feet. To achieve these speeds, it would require either a ramjet, early scramjet, or a unique propulsion system known as the pulse wave detonation engine. This pulse wave detonation engine uses small fuel detonations to propel the aircraft, resulting in a distinctive contrail resembling a ring of donuts. What sets the propulsion apart is that it operates on supersonic fuel detonation, making it more efficient and faster than traditional jet engines or rocket engines. The aircraft's unique capabilities would enable it to fly beyond the range of current anti-aircraft defenses while offering a range greater than the SR-71. The Aurora's primary mission was espionage, bridging the gap between spy satellites and slower aircraft or drones. It might operate either autonomously or with one or two pilots. The details are unclear, given the limited information available. Some even argue that the name Aurora actually referred to the B-2 stealth bomber program and not a separate aircraft. The U.S. government maintains that evidence supporting the Aurora is circumstantial or speculative. Nonetheless, experts believe that advancements in technology have finally caught up with the ambition that launched the program decades ago, and the Aurora plane may still be out there. NASA has been trying to get astronauts into deep space for many decades, and now it seems that goal is about to be achieved. They've tested many experiments over the years, and many have failed, but some increasingly prove that they could help us explore space better. As we proceed, we'll take you through the timeline of experiments NASA has undertaken and how they finally came up with this incredible light-speed machine that shocks everyone and scares some. Space opens up a world of possibilities, and many things we believe to be impossible will prove possible when we eventually get to explore the galaxies that lie beyond. This makes NASA's continuous efforts impressive, and many are curious to know how they do what they do. If you're curious too, join us as we explore how NASA builds the impossible light-speed engine to break the laws of physics. The big challenge with sending humans into space is that space itself is incredibly vast. That's why scientists came up with the concept of light years just to describe them. Light year defines the distance light can cover in a year, roughly 6 trillion miles or 10 trillion kilometers. For instance, light takes about 1 second to travel from the moon to our eyes, so the moon is 1 light second away. On the other hand, sunlight takes about 8 minutes to reach us, making the sun 8 light minutes away. Alpha Centauri, the closest star system, is 4.3 light years away, and objects beyond our solar system can be billions of light years out. That's why when astronomers observe distant objects, they're essentially looking back in time. Scientists have been trying to figure out how to travel at such a mind-boggling speed. Elon Musk's SpaceX aims to colonize Mars, but the journey takes several months, or even close to a year, depending on the planet's positions. With the speed of light travel, the trip could be made in less than 4 minutes. However, to go faster, we need more kinetic energy, and it takes an enormous amount of energy to achieve even a tiny fraction of light speed. The M-Drive is an example. It is a device with a tapered copper cylinder and a resonant radiation field inside, causing microwave standing waves to bounce around. It uses microwaves to create thrust without traditional fuel. That's a game changer because conventional rockets have to carry a ton of mass to move forward. Roger Scheuer, the M-Drive's inventor, claims that thrust happens due to differential radiation pressure between its ends. But this explanation breaks the law of conservation of momentum unless those photons escape the device and turn it into a photon thruster. And even if they do, the thrust is tiny. EagleWorks, NASA's Advanced Propulsion Physics Laboratory, tried to replicate Scheuer's measurements in various tests, but none have been conclusive. They even ran the latest test in a vacuum chamber to rule out thermal convection messing with the results. They used a torsion balance to measure any force accurately. The results showed a positive thrust at different power levels, but it's still way smaller than Scheuer claimed. Even at its best, it's not enough to power hoverboards, let alone time-traveling machines. However, it could be useful for long-range space travel since it eliminates the need for propellant. Many scientists also remained skeptical about the M-Drive capabilities, and tests suggested that previous positive results were due to external forces. But here's where it gets interesting. The warp drive, a concept that seemed like science fiction, has shown promise. Dr. Eric Lentz, an experienced physicist, has been working on making it a reality. While he wasn't the first, his work holds potential. The warp drive, if successful, could revolutionize our understanding of the universe and space travel. Back in 1994, a Mexican mathematician named Miguel Alcubierre sparked the whole warp drive discussion with his proposal, now known as the Alcubierre warp drive. However, it's essential to remember that Alcubierre didn't set out to design a spaceship propulsion system. Instead, he was diving into the realm of theoretical physics and exploring the possibilities allowed by Albert Einstein's general theory of relativity. In the early 20th century, Einstein's groundbreaking theory introduced the idea that the fabric of space and time is not static, but can warp and bend in the presence of energy and matter. This revolutionary concept was a foundational pillar of modern physics, fundamentally altering our understanding of the universe. Alcubierre's genius lay in taking these theoretical concepts and pushing them to their limits. He wondered whether it might be possible to manipulate space-time to facilitate faster-than-light travel, essentially creating a shortcut through the cosmos. His theoretical framework involved the creation of a warp bubble or warp field around a spaceship, within which space-time would warp in a specific manner. This warp field would compress space behind the spaceship while expanding it in front, generating a propulsion effect without the need for conventional rocket propulsion. It was as if he had found a way to ride on a wave of space-time curvature. Now, what made Alcubierre's work so groundbreaking was not just the audacity of the idea, but also the fact that it was a legitimate solution to the Einstein field equations, the mathematical foundation of general relativity. In essence, it was a valid interpretation of the theory, even though it relied on hypothetical concepts like exotic matter with negative energy density. Alcubierre's proposal opened the door to discussions about the potential for faster-than-light travel, a concept that had long been the stuff of science fiction. His work caught the attention of both the scientific community and science fiction enthusiasts, leading to extensive discussions and debates. One of the biggest stumbling blocks is the requirement for exotic matter with negative energy density. This exotic matter is crucial for creating the warp bubble, allowing spacecraft to travel at warp speed. Yet exotic matter remains purely theoretical and has never been observed in the natural world. Additionally, the energy demands of a warp drive are astronomical, quite literally. Alcubierre's original calculations suggested that it would take more energy than the entire observable universe contains to propel even a moderately sized starship. While subsequent studies attempted to reduce this energy requirement, it remained far from practical. Another puzzle is the issue of causality and paradoxes. Warp drives have the potential to create closed, time-like curves, leading to time travel paradoxes like the grandfather paradox. Resolving these paradoxes poses a significant challenge. However, recent developments have reignited hope for warp drives amidst these challenges. Researchers at the Advanced Propulsion Laboratory at Applied Physics have proposed a new model for a physical warp drive. Unlike previous concepts that relied on negative energy or exotic matter, this model utilizes the behavior of space-time bubbles to achieve warp-like travel, as already mentioned. In the following years, subsequent studies aimed to refine and address some challenges posed by the Alcubierre warp drive, such as the enormous energy requirements and the paradoxes associated with time travel. Scientists and theorists grappled with the theoretical implications, exploring whether such a propulsion system could ever become a reality. Chemical rockets, while effective, might seem a bit primitive when you break them down. You load up tons of fuel, either liquid or solid, add an oxidizer, set it all on fire, and let the explosive gases provide the push needed to send your rocket in the opposite direction. However, they're inefficient. The Falcon Heavy, for example, is a behemoth weighing in at 550 metric tons. It carries nearly 400 tons of fuel and oxidizer. The first stage burns for a mere 162 seconds, and the second lasts 397 seconds. In total, that's about 9.5 minutes of burn time. This inefficiency has driven scientists to explore alternative forms of propulsion, especially for long journeys in space. However, Alcubierre's proposal has helped us make strides in developing concepts like ion drives and warp drives. One of the most promising solutions so far is the ion thruster. These ion drives are relatively slow but incredibly fuel efficient, making them a good option for various space missions. While the most efficient chemical rockets eject hot gases at about 5 kilometers per second, ion engines kick it up several notches by expelling individual atoms at a blistering 90 kilometers per second. This higher velocity translates to a significantly more efficient acceleration. While the best chemical rockets operate at around 35% efficiency, ion engines clock in at an impressive 90%. These engines can run for days, weeks, or even months, tirelessly accelerating long after chemical rockets would have guzzled up their fuel. So once you're beyond a planet's gravity well, they become incredibly efficient tools for making dramatic changes in velocity. NASA and other space agencies have embraced ion engines with great success across various missions, though they still looked for better options. They've tinkered with this thruster concept for decades, but initially hesitated to use it in active missions due to the potential risks involved. That all changed with NASA's Deep Space One mission, launched in 1998. This spacecraft was a bundle of daring technologies, including low-power electronics, solar concentrator arrays, scientific instruments, and a solar electric propulsion system. The engine was run for extended periods, allowing it to make up-close observations of asteroids, comets, and even Mars. Building on Deep Space One's triumphs, NASA's Dawn mission took it up a notch, featuring 3 redundant ion engines. These engines enabled the spacecraft to orbit the asteroid Vesta, gather data, then break orbit and head to asteroid Ceres for even more exploration. Astonishingly, there might still be fuel left for additional asteroid visits. To give you a sense of their acceleration, Dawn can go from 0 to 100 kilometers per hour in just 4 days of continuous thrusting. Ion thrusters have also played roles in various other missions. ESA's Smart 1 spacecraft used them to travel from Earth orbit to lunar orbit, and the Japanese Hayabusa spacecraft relied on ion engines. These engines have even been put through rigorous testing on Earth, where they continuously operated for more than 5 years. As if these successes weren't exciting enough, the future holds even more promise for ion thrusters. Researchers are exploring ways to enhance their output. One approach is to significantly increase the amount of electricity used to accelerate the ions. NASA once contemplated a mission called the Jupiter Icy Moons Orbiter, powered by the nuclear electric xenon ion system engine, which could have explored Jupiter's moons using ion thrusters. However, the mission was canceled back in 2005. Another avenue involves developing high-thrust versions of ion engines, like NASA's X-3 Hall thruster, capable of producing 5.4 newtons of force, a significant leap from the thousandths of newtons seen in previous thrusters. At full power, this technology could shorten the flight times for human astronauts traveling to Mars to just a few months. Engineers are gearing up for 100-hour tests of the X-3 to assess its long-term operational capabilities. The European Space Agency is also experimenting with an air-breathing ion engine. Instead of lugging propellant, this engine would draw in air molecules from the atmosphere in low Earth orbit, ionize them, and then expel them. Since the spacecraft would have access to abundant solar electricity and atmospheric propellant, it could operate for extended periods without refueling. This innovation could revolutionize space travel, allowing spacecraft to function at lower altitudes and space stations to remain in low Earth orbit indefinitely without requiring periodic boosts. One of these groundbreaking technologies is the ion drive. When the idea of ion drives was introduced, many skeptics believed it couldn't generate enough power to move a spacecraft. However, it turns out that ion drives are not just theoretical, they actually work. NASA recognized their potential and 2016 awarded a significant contract to Aerojet Rocketdyne to develop an advanced solar electric propulsion system. This system, also known as the Hall effect thruster, relies on converting solar power into electricity and then using it to accelerate ions, which in turn generates thrust. With the amount of development the ion drive has seen over time, some might wonder why much hasn't been done in the utilization of warp drives. Well, there are a couple of hiccups with the warp drive theory. First, scientists are still scratching their heads trying to figure out how to conjure up one of these nifty warp bubbles in a space that doesn't already have one. And even if they did manage to pull off the bubble trick, there's no exit strategy. Once you're cruising inside that warp bubble, there's no known way to make a graceful exit. In 2012, EagleWorks even decided it was high time to dive into the possibility of using the warp drive. They made an interferometer, a gadget designed to sniff out any strange spatial distortions caused by the expanding and contracting spacetime of the Alcubierre metric. However, all of this led them to a dead end. Probably sometime in the future, scientists will finally understand how to use warp drives to help humans explore deep space. Now, their interests have moved from ion thrusters to nuclear thermal engines. There was a recent collaboration between NASA and DARPA, the Defense Advanced Research Projects Agency. This collaboration, known as the Demonstration Rocket for Agile Cislunar Operations, or DRACO, aims to speed up the development of this space-age engine. The plan is to have this advanced nuclear thermal propulsion technology running by 2027. With this snazzy new tech, astronauts could whiz to and from deep space in no time. Nuclear thermal rockets cut down the time it takes to get places, and that's a big deal when you're talking about places as far as Mars. Longer trips mean more supplies and more complicated systems, and we'd rather keep things streamlined. But there's more to it than just speed. Nuclear thermal rockets come with extra perks. They boost the capacity for scientific payloads and give instruments and communication systems more power to work with. At their core, these rockets have a fission reactor that generates incredibly high temperatures. This heat is then transferred to a special liquid propellant. When the propellant is released through a nozzle, it expands and shoots out, propelling the spacecraft forward. It's a high-tech way of achieving propulsion and can be 3 times more efficient than conventional chemical methods. The space domain is more critical than ever, impacting everything from commerce to scientific discovery and national security. These advances in space technology through the Draco nuclear thermal rocket program will make transporting materials to the moon and eventually humans to Mars more efficient and faster. It's important to note that the last time the United States conducted nuclear thermal rocket engine tests was over 50 years ago. This collaboration signifies a significant leap forward in space nuclear technology. Recent advancements in aerospace materials and engineering are ushering in a new era, setting the stage for an Earth-Moon economy. But the collaboration doesn't stop here. NASA, the Department of Energy, DOE, and industry are working on various initiatives to harness nuclear power for space exploration. They're developing concepts for nuclear power plants that can be used on the Moon and Mars. These efforts are part of a broader plan to improve engine performance and support long-range space exploration goals. Some people have wondered why NASA moved from ion thruster engines to this new nuclear development that seems to break the laws of physics. Well, ion and plasma thrusters indeed have their merits, but they also come with some significant drawbacks that must be considered. As already mentioned, they suffer from a notably low average thrust. This means they can't provide the kind of forceful propulsion that traditional chemical rockets offer. Also, the thrusters demand substantial electrical power, often ranging from tens of kilowatts to multiple megawatts. To put it in perspective, that's like having a high-powered, electricity-hungry appliance running continuously. This poses a challenge because generating and storing such large amounts of electricity in space is no small feat. Moreover, there's the issue of potential contamination. Ion and plasma thrusters can pose a risk of contaminating the spacecraft's exterior with substances like mercury or cesium. This contamination can be problematic for various reasons, including potential damage to sensitive instruments and equipment on board. In contrast, nuclear thermal engines offer a significant advantage in terms of thrust when compared to ion thrusters. They can provide that burst of power needed to propel a spacecraft quickly. When hydrogen, specifically liquid hydrogen or LH2, is used as the propellant, these engines boast a higher specific impulse and greater exhaust velocity than traditional chemical rockets. This translates to improved efficiency, as the spacecraft can cover more distance using less fuel. However, it's important to note that while it's more efficient, it's not a quantum leap in efficiency. In a vacuum environment, nuclear thermal engines have the potential to offer a lower empty weight for the vehicle and a higher payload percentage. This is like the engines shedding excess baggage and optimizing their cargo space. This feature is particularly advantageous for long-distance missions where every kilogram of payload matters. In essence, while ion and plasma thrusters have their own set of benefits, nuclear thermal engines step in with their higher thrust capabilities and efficiency advantages. It's all about choosing the right tool for the job and weighing the pros and cons to ensure the success of space missions. This doesn't mean these engines don't have challenges either. Once that nuclear core is up and running, approaching it becomes a risky endeavor. It and the surrounding support structures become intensely radioactive. Crew members and most robots can't get anywhere near it. They must maintain a safe distance of several hundred meters, which adds to the overall weight and complexity of the spacecraft. Beyond this, there are other problems this rocket engine poses, but scientists keep working to make it better. NASA and DARPA's collaboration aims to make space missions more efficient and set the stage for a new era of space exploration. Thanks for watching. If you enjoyed this video, then click on the link appearing on your screen right now. It will lead you to another one of our interesting videos. See you there.